Good afternoon. My name is Adrian van der Westhuizen and the title of my project is IoT-enabled hydroponics. The problem of my project can be stated as follows. The quality of the nutrient solution within an active hydroponic system must be monitored and autonomously controlled. An overview of my proposed solution can be seen on screen. The end user can make use of a mobile device to connect to a Node.js server running on Google Cloud Platform. This server in turn connects with a sensor module that's placed close to the hydroponic system. The sensor module makes use of pH and EC sensors to gather data about the nutrient solution within the system. The controller can also make use of peristaltic pumps to dispense nutrients into the system. The backend design can be seen on screen. A NoSQL database management system called MongoDB was used to store the measurement data. All users and the devices are stored in the Nukes admin database. Each user is then assigned a DB with its respective devices and their measurements. Wireframes were used to design the front end of the system. These wireframes for the most important pages can be seen on screen. For general firmware design, I made use of flow diagrams. The main flow of the program running on the sensor and control module can be seen on screen. First, the storage and event groups are initialized, then separate managers for the different aspects of the sensor module are initialized. This includes things such as Wi-Fi, OTA, MQTT, sensors, and the dosing. And then the measurement and control tasks are started. To test the system, both the sensors and dosing pipes were placed into a bucket. On screen we can see the data, three hours worth of data that was recorded. We can see at 4:53 the system is installed. Immediately dosing is applied, nutrient solutions are pumped in and pH down is pumped in. More or less at 5:54 we see that the system stabilizes as the EC and pH reach the desired levels. At 6:40 I removed half of the water from the bucket and replaced it with new water. Approximately at 6:50 dosing is applied again, and at 7:33 the system once again stabilizes in the desired ranges. Referring back to the problem statement, we see that it consists of two aspects: monitoring the quality of the nutrient solution and autonomously controlling it. Since we're gathering data and displaying it to the end user via visual graphs, we solve the first problem by monitoring the solution. And from the bucket experiment described in the previous slide, we saw that the levels could also be autonomously controlled. Improvements to the solution include using industrial grade sensors, since these sensors that we used are prone to calibration drift, adding additional sensors such as O2, humidity and light intensity sensors, sending push notifications when the measurements are outside of the desired ranges, and incorporating the EC and pH levels of different plant species into the web app to lessen the technical expertise needed.